Hello, everyone. Thank you for joining this session. I am Akshaya. I am a senior consultant at SquareShift Technologies. And today we are going to talk about how we helped a global digital commerce agency migrate their analytics workload to Elastic Cloud. Along with me, I have Ilango, CTO of SquareShift Technologies, who will be covering the second half of this session. And to give a brief about SquareShift, we are a niche consulting firm with expertise in digital, data, cloud, and cybersecurity services. We are an Elastic Premier partner providing consulting and implementation services for startups to Fortune 500 companies. Let us take a look at these numbers. Is it possible for an observability solution to produce these kind of results? This is going to be the crux of what we wanted to share today and how we were able to create a high impact on one of our clients. To set the context, the client was in the business of providing digital storefronts for large retail stores. They serve over 40 plus customers and provide business analytics dashboards that are very valuable during the peak holiday seasons. The analytics information was sourced from a combination of customer behavior from the browser analytics and transactional systems. As a growing business, our client realized that the current solution was not scaling to meet their business needs, and they were looking to upgrade to a better solution. The challenges with adopting a new solution were threefold. To start with, they lacked the expertise to migrate data from a legacy stack. They were running an unsupported version of Greylog, and Greylog leveraged Elasticsearch to store all the collected data. The clients had invested heavily in building custom dashboards using this data. As mentioned earlier, during the peak holiday season traffic, there were constant failures and they were at a very high risk of failure in the upcoming season. Finally, the browser analytics scripts were already embedded into multiple websites, and changing this would require at least 3 to 6 months of development. So they were looking for a solution that involved no change at all to the front end. Now let us take a look at the architecture before migrating to Elastic Cloud. As you can see, there were Greylog RUM scripts running on the browsers. Web events from each client were sent as JSON payloads to the Greylog in the Greylog extended log format. Greylog then pushed these events to Elasticsearch, from which Kibana and the Grafana dashboards were created. While exploring various solutions, here are some of the key considerations. We wanted to move them to the latest and the greatest version of Elasticsearch. Any production deployment requires robust monitoring and management. So we leveraged the Elastic Cloud Managed Services to host the instance. This also gave back valuable bandwidth to the team to build out new features. And to remove the dependency on front-end changes and the associated deployment to multiple sites, we deployed a temporary infrastructure to mimic the Greylog servers. The infrastructure was running at peak capacity even during the lean periods. So to cut down the operational costs, Elastic Cloud's auto-scaling capabilities provided the flexibility to operate at an optimal capacity. During the discovery process, we also observed that though the large fast drives were provided for storage, the active query period was only the last 30 days. The rest of the data could have been hosted on economical drives. The data migration approach had two phases, historical and real time. The historical data was pre-migrated before the actual cutover. And during the actual cutover phase, the delta changes were migrated to the new system. The historical data had many deprecated types and required mapping changes. We also made sure to validate the data at each stage of the migration process. And once the historical data was migrated, the end users also validated the new dashboards against their existing systems. And it took us a total of about 4 days to migrate the historical data. And for the real-time data, we published DNS changes for the cutover to new infrastructure. We leveraged queuing system to stage the events during the final cutover. And we also used ingest pipelines for the data transformations. It took us just 4 hours for the Delta data processing and the final cutover. I now hand over this session to Ilangu. Thank you.
Thanks, Akshaya. Hello, everyone. I'm Ilangu. I'm excited to be part of ElasticON and share some of our experience with the broader community. We are now looking at the deployment architecture post-migration. If we start from the top, we can see that Greylog real user monitoring clients were able to continue to send data without having to make any changes. Newer clients will start to leverage the powerful Elastic RUM capabilities, while legacy clients will be gradually migrated to the new setup. In order to handle these legacy clients, we introduced a temporary layer built using a combination of AWS components and Logstash to mimic the Greylog server. This layer was responsible to perform transformations that were originally performed by Greylog and then dropping the events to Elastic Cloud. Once these legacy clients are migrated off, this intermediate layer can be retired. The intermediate layer also gave us the ability to stage events during the final cutover. The events were stored in SQS, and once the Delta events were processed by Elastic Cloud, the queue was drained, and we were able to catch up to the real-time flow within an hour. The beauty of this setup was that the existing dashboards on both Kibana and Grafana work with only a few tweaks. There were some key learnings and things that we would do differently when performing migrations like this. The first one was Elastic Cloud being a blessing in disguise. This migration involved migrating snapshots through 2 additional versions of Elasticsearch. This required a temporary cluster to be stood up for restoring these snapshots. Elastic Cloud has hidden options to enable older versions for the purpose of migration. Do talk to your friendly account manager to enable these older versions. Historical data migration involves moving huge volumes of data. So do account for data transfer costs, especially when copying data out of the cloud. Finally, this migration involved migrating about 9,000 indices. So any automation will be extremely helpful. Specifically, automation around checks and balances at each step is critical. Making sure that at each step, the document counts is being matched between the source and destination systems. As this migration had multiple hops, automating this validation helped us identify errors at the earlier stages of the migration. To summarize the impact of this migration, our client was able to efficiently move large volumes of data with ease. By leveraging the auto-scaling features of Elastic Cloud and thereby running an optimal capacity, it resulted in lowering the TCO by 60%. With infrequently data now housed in the frozen tier, the client did not have to worry about retention periods. Only a subset of data was now having to be housed in the hot tier, and the rest were automatically moved to frozen tier by index lifecycle policy. I hope this session was informative. We would like to thank our project team, Varun, Prasad, Harsha, Pratap, and the Elastic product marketing team members, George Gobar and Evan. Do launch a free trial and explore Elastic Cloud features. Reach out to SquareShift if you have any questions on upgrades or migrations. We also offer a free 2-hour discovery session to discuss your upgrades or migration use cases. Thank you.